Hello everyone, welcome to the next video on DC to DC boost converter. In the previous in the previous part one, we have seen the numerical where ripple voltage and ripple voltage across the capacitor and ripple current to the inductor is mentioned in a percentage. But in this problem, these values are given directly. So here it is a 50 volt DC supply. So source voltage is a 50 volt. Okay, in this problem, the source voltage is given as a 50 volt and the output voltage, it is connected to the load of 75 volt 5 ampere. So here the voltage rating is given as a 75 volt and the current rating is also given in the problem, that is a 5 ampere. So you can say total load is of 735 watt load, which is 375 watt load if you multiply V0 into I0. We have to design a boost converter with the following specification. The peak to peak inductor current is limited to 0.5 ampere, means delta IL value is to limited at the 0.5 ampere. Instead of percentage, this value is directly given in the problem, and peak to peak output voltage is limited to 100 millivolt. Means V0, the delta V0 variation in the output voltage is allowed to be 100 millivolt, that means 0.1 volt is allowed, and the switching frequency is given as a 50 kilohertz. Determine the voltage rating, inductor rating, capacitor rating, switch rating, and diode in this case. So also draw the circuit diagram showing all the ratings. So in this problem, we have to design this circuit. So first determine the duty cycle. So duty cycle formula is the V0 minus Vs upon V0, or you can say it is a 1 minus Vs by V0. You can implement any formula here. So duty cycle is equal to 75 minus 50 upon 75. It comes to 0.333, that is 33.3%, or you can say it is a 1 by 3. The accurate value is 1 by 3. Now, what is the value of load current? Load current directly given in the problem, it is of 5 ampere. So let us determine the inductor current. The formula for the inductor current is I0 upon 1 minus D. So I0 is 5 upon 1 minus 0.33. It comes to 7.5 ampere. Now, ripple in the inductor current is given in the problem as a 0.5 ampere. Ripple is directly given in this problem. Let us determine the inductor rating. So, inductor rating is equal to Vs into D upon Fs into delta FL. So, Vs is 50 volt, D duty cycle is 0.333 into frequency is 50 kilohertz. So, 1 upon kilo will answer give in the milli. So, into delta IL is the 0.5. So if you calculate it, it gives you 667 millihenry, or you can say 667 microfarad answer. So first rating you got here, let us write down the inductor rating. So inductor rating in this case is 0.667 millihenry. And what is the highest value of the current through the inductor? Because inductor is decided on based on the rating of the inductor current. So inductor current, maximum inductor current is equal to IL plus delta IL by 2. So IL value is the 7.5 ampere plus delta IL is 0.5 divided by 2, that is 0.25. So the answer is 7.75 ampere. So answer will be 7.75 ampere. So by this way, we can calculate the value of the inductor. Now let us calculate the value of the capacitor. So to determine the value of the capacitor, so let me make it a full page view. So to determine the value of capacitor, what is the capacitor ripple voltage? The capacitor ripple voltage is given as a 100 millivolt, that is a 0.1 volt, and value of the capacitance is determined by I0D upon Fs into delta Vs. So 5 is the I0 value. Duty cycle is a 0.333 divided by 15 to 0.1. If we calculate it, that value, because the frequency is in kilo, the answer is 0.3333 millifarad, or you can say 333 microfarad. So let us write down the capacitor rating. The capacitor rating is 333 microfarad with the output voltage is of 75 plus delta V. Delta V value is zero point 0.1. So delta V 0.1 divided by 2, it comes to 75.05 volt. That is the rating of the capacitance is required. Now let us determine the MOSFET rating, MOSFET switch rating. The MOSFET must be V0 plus delta VC by 2. So V0 is equal to 75 and delta VC is the 0.1 volt. So zero point 0.1 divided by 2, it comes to 75.05. And ISW is equal to IL plus delta IL by 2. So here the IL value is the 7.5 ampere plus delta IL is equal to zero point 0.5 divided by 2. So it comes to 7.75 ampere. So sorry, here I have written the wrong answer. So this answer must be 7.75 ampere. So let me correct here. So switch rating must be 75.05 volt and the current rating is the 7.75 ampere. Now let us calculate the next diode rating. In case of diode, V0 plus delta Vc by 2 must be the diode rating, that is 75.05. So diode rating is also coming as 75.05 volt and the ID value is the greater than or equal to IL plus delta IL by 2. So the value of the IL is the value of the IL is 7.5 ampere plus delta IL by 2, that is 0.5 by 2, that is 0.25. So it comes to 7.75. So sorry, the wrong answer is written here. It is 7.75 ampere. So this rating must be 7.75 ampere. So if we simulate this or if you design this circuit using this value, so you will get the required specification output. Hope you like this problem of the numerical on DC boost convert, DC to DC boost converter. Thank you for watching the video. Kindly share with friends, give the likes to the video and subscribe my channel. Thank you.